The halogens are in group 7 of the periodic table. Going down from the top, you have fluorine, chlorine, bromine, iodine, and astatine. If we have a look here, you can see that as you go down the group, the boiling point and the melting point increases. So fluorine has a melting point of about minus 220 and a boiling point of about minus 190. And chlorine has a boiling point of about minus 30. This continues all the way down to astatine, which has a very high melting point and boiling point. This helps to tell you what state they are at room temperature. So because fluorine boils at minus 190, it's a gas at room temperature. Same with chlorine. Bromine doesn't boil till about 60 degrees, therefore it's a liquid at room temperature. And iodine and astatine both melt over 100 degrees, therefore they're both solids at room temperature. As you go down the group, the colour goes from a very light colour to a dark colour. So we start off with fluorine, which is a light yellow colour, a light yellow gas. Chlorine is a yellowy green gas. Bromine is an orangey brown liquid. Iodine is a purple solid. And astatine is a dark grey solid. As you go down the group, melting point and boiling point increase. And reactivity decreases. Therefore, fluorine has the lowest melting point and is the most reactive. And astatine is the least. There are two types of reactions you need to know about. One of them is when you react a metal with a halogen. When this happens, you get something called a metal halide. So for example here, aluminium and chlorine react together to make aluminium chloride, and iron and bromine react together to make iron bromide. They are both examples of metal halides. What would copper and iodine react together to make? The answer is copper iodide. Also, when hydrogen and halogens react together, you get something called a hydrogen halide, such as hydrogen and chlorine reacting together to make hydrochloric acid, which is also known as hydrogen chloride. And so on. The last bit you need to know is about displacement reactions. This is where a more reactive halide will swap places, displace a less reactive halide. So for example, if I had lithium chloride, in this case the carrot, before you criticise my artwork, is lithium, and chloride is my fantastically drawn rabbit. If a more reactive halide were to come along, so for example fluorine, the more reactive nonmetal will swap places with the less reactive nonmetal. So in this case, fluorine and chlorine will swap round, so the fluorine will be part of the compound. Just like that. So a word equation for that will be lithium chloride plus fluorine goes to lithium fluoride plus chlorine. So if we have a look at the example on the GCSE Bite-Size website, we have three different compounds: potassium chloride, potassium bromide, and potassium iodide. If we add in chlorine water to each of these, you will see that in the first one there is no reaction. This is because you're adding chlorine to potassium chloride. It's the same reactivity because it's the same element, so it will not do anything. However, in this one here where we had potassium bromide, chlorine has now swapped places with it because it's more reactive and removed bromine from the compound. So we started with potassium bromide and chlorine, and we ended up with potassium chloride and bromine. And finally, we had potassium iodide, added chlorine to it. Because it's more reactive, it's displaced it. Therefore, we're left with potassium chloride and iodine. This continues, so if I were to add bromine water to the three solutions, you will see nothing happening in these two because it's less reactive than chlorine, the same as bromine, but here there will be a reaction because it's more reactive than iodine. And then finally, add iodine to the three solutions and nothing will happen because it's less reactive than these two, so no reaction can occur. And this final one here, it's the same reactivity because it's the same element, so again, nothing will happen. You also need to be able to write balanced equations for displacement as well as word equations. So if you were asked in the exam to write a balanced equation for the reaction between sodium chloride and fluorine, this is what you do. Start off by writing out what the products are in a word equation. So because fluorine is more reactive than chlorine, it will swap places with it. So you get sodium fluoride and chlorine. If you're not sure what the formula for sodium chloride is, remember sodium's in group 1, chlorine's in group 7. Therefore, they have a charge of +1 and -1. They're balanced, you don't need to do anything. So you have NaCl. All of the halogens go around in pairs. So F2, Cl2, Br2, I2, and At2. So fluorine is F2. Any metal halide that's reacted with an alkali metal will have a ratio of 1 to 1. So sodium fluoride is that, and then you've got chlorine, which as I've said is diatomic, goes around in pairs. The next thing you need to do is balance it. So work out how many of each element you've got on each side. So on the left, we've got 1 sodium, 1 chlorine, and 2 fluorines. On the right, we've got 1 sodium, so that's balanced. We've got 2 chlorines, so that's not balanced. And we've got 1 fluorine, so that's not balanced. So what you need to do is choose something to multiply. So we can start over here. Let's try doubling that. We've now got 2 sodiums. That's no longer balanced. But our fluorines are. So the easy way to get around this now is double this on this side. We have 2 sodiums, which is balanced. And we have 2 chlorines, which is balanced. So my balanced simple equation is 2 NaCl plus F2 goes to 2 NaF plus Cl2. This pattern continues for every single displacement reaction. The final little bit is the uses of the halogens. So for this you need to know what the uses are for each of the halogens. You should be able to remember from last year that chlorine is toxic, therefore it can be used to kill bacteria and used as a bleach. As a result of this, it should only be used in a fume cupboard or in a well ventilated area. This helps to get rid of the toxic chemicals. This is the same for iodine and any other chemicals that are used. The final section of this video is going to show you why when you go down group 7 reactivity decreases. So why fluorine is more reactive at the top than astatine at the bottom. As you should know that all elements in group 7 have 7 electrons in the outer shell. Therefore all of them want to gain 1 electron. So they all want 1 electron. What holds these electrons around the atom is the electrostatic charge, that force of attraction between the negative electrons and the positive protons. So if we have a look at the top atom here, the distance from the outer shell to the central nucleus with the positive protons is a lot smaller than if we have a look here. This gap here is much, much bigger. So the stronger pull on the electron is going to be up here. So that electron is easily going to attract there. Whereas down here it's going to take a lot longer to attract that electron. Therefore, because this one up here, fluorine, attracts that outer electron much quicker, we say it's more reactive. It will react a lot quicker than astatine. This also helps to explain the melting points and boiling points. So fluorine's outer shell is closer to the nucleus, the pull on the electron is stronger, and therefore it gains its electron quicker,